Hi everyone, welcome to the channel Math for me and you. Let's learn maths together. Hello, I am Sindhu Suresh. This video helps you in practicing exercise 8.4 question 5 part 8, 9 and 10 from the chapter Introduction to Trigonometry. I have already prepared videos about part 1, 2, 3, 4, 5, 6 and 7 from question number 5. I shall give you the link in the description box. Prove the identity sin a plus cosec a the whole square plus cos a plus sec a the whole square is equal to 7 plus tan square a plus cot square a. We are going to prove LHS equals RHS. So write LHS again. Sin a plus cosec a the whole square plus second bracket cos a plus sec a the whole square. Each bracket is of the form a plus b the whole square. In the next step, we can write the expansion, that is a square plus b square plus 2ab form. Here a equals sin a. So the first term is sin square a plus in place of b cosec a. So we can write b square, that is cosec square a plus 2ab form, that is 2 times sin a times cosec a plus second bracket also we are expanding using the identity a plus b the whole square, which is equal to a square plus b square plus 2ab form, that is cos square a plus sec square a plus 2 cos a times sec a. See the ratios sin square a and cos square a. Let's write them together. So in the next step we are starting with sin square a. After that we are writing cos square a, sin square a plus cos square a. Next ratio is cosec square a. We have studied the identity cosec square a is equal to 1 plus cot square a. Now we can replace cosec square a with 1 plus cot square a plus next is 2 sin a times cosec a. 2 sin a times what is cosec a? Reciprocal of sin. So we can write cosec a as 1 divided by sin a plus the next term is sec square a. We have studied the identity sec square a minus tan square a is equal to 1. Therefore, sec square a is equal to 1 plus tan square a plus next is 2 cos a times sec a. So we write 2 cos a times sec a is 1 divided by cos a. In the next step, we can use the identity sin square a plus cos square a is equal to 1. So we are replacing sin square a plus cos square a with its value 1 plus 1 plus cot square a plus 2 sin a times 1 by sin a. Sin a and 1 by sin a, let's cancel. And then we get there 2 plus 1 plus tan square a plus the last term 2 times cos a times 1 by cos a. Cos a and 1 by cos a, let's cancel. So we get there 2. Let's add the numbers together. 1 plus 1 plus 2 plus 1 plus 2. So the total we get there 7. Plus cot square a plus tan square a. Let's write same as in the RHS. So we could write tan square a plus cot square a. This is the RHS. So we could write it is equal to RHS. What we are getting is LHS equals RHS. That means we have proved the given identity. Part 9. Prove the identity cosec a minus sin a times sec a minus cos a equals 1 by tan a plus cot a. Prove the identity means we have to show LHS equals RHS. So we are writing LHS is equal to cosec a minus sin a times sec a minus cos a. In the next step, we will change cosec and sec in terms of sin and cos. So cosec a we can write as 1 by sin a because this is the reciprocal of sin minus sin a we are writing as sin a divided by 1. So it will be of the form 2 fractions to be subtracted. Next bracket sec we are changing as 1 by cos. Sec a equals 1 by cos a minus cos a. Cos a we can give a denominator 1. Next step, first bracket we are going to subtract 2 fractions. So we need LCM as the denominator. Sin a times 1, that is sin a is the common denominator. We can write sin a as the denominator and cross multiply to get the numerator. 1 times 1, 1 minus sin a times sin a is sin square a. Next bracket. Here also two fractions to be subtracted. We need the LCM as the common denominator, which is cos a times 1 is cos a. Cross multiplying we get the numerators. 1 times 1 is 1 minus cos a times cos a is cos square a. Look at the numerators, 1 minus sin square a and 1 minus cos square a. We have studied the identity sin square a plus cos square a is equal to 1. What is 1 minus sin square a? Move sin square to the right side. It becomes 1 minus sin square a. The value is equal to cos square a. Similarly, we can find what is 1 minus cos square a. If we move cos square a to the right side, it becomes minus cos square a. 1 minus cos square a equals sin square a. In the next step, we are replacing the numerators. So, the first numerator 1 minus sin square a becomes cos square a divided by sin a times second numerator 1 minus cos square a, we can replace with its value sin square a divided by cos a. From numerator we could cancel 1 cos a with denominator, and also sin 1 sin a we can cancel from numerator and denominator, which is equal to cos a times sin a. But is this the RHS? No, this is not the RHS. This is not what we need. So what we can do is we can take the RHS 1 by tan a plus cot a and simplify, and let's see whether we get this cos a times sin a as answer or not. So we can start with RHS, the right hand side. RHS is equal to 1 by tan a plus cot a. Tan a and cot a we can replace in terms of sin and cos. Tan is sin by cos and cot is its reciprocal, that is cos by sin. So we are writing 1 divided by tan a we are changing as sin a divided by cos a plus cot a we could write the reciprocal of tan, which is cos a divided by sin a equal to 1 divided by. Now we are going to add the two fractions. What is the common denominator? LCM, which is cos a times sin a. Cross multiply to get the numerators. Sin a times sin a is sin square a plus cos a times cos a is cos square a. So we get there sin square a plus cos square a divided by cos a times sin a. In the next step, 1 divided by. What is sin square a plus cos square a? We have studied the identity. The answer is equal to 1 divided by cos a times sin a. Here the meaning of this expression is 1 divided by a fraction. So what we can do is 1 multiply with the reciprocal of the fraction. 1 times reciprocal of 1 divided by cos a sin a is cos a sin a divided by 1. So what is the answer we are getting? 1 times cos a sin a is cos a sin a divided by 1 means same. So the answer cos a times sin a. It's the simplified LHS answer. So what we could write? We could write LHS answer is equal to RHS answer, or LHS equals RHS. That means we have proved the given identity. 10th identity is 1 plus tan square a divided by 1 plus cot square a is equal to 1 minus tan a divided by 1 minus cot a the whole square is equal to tan square a. In this question we have to prove the first bracket equals tan square a and also the second bracket equals tan square a. For that, if we consider the first bracket as LHS, we have to show the answer is equal to tan square a. That means tan square a is the RHS. And if we take the second bracket as LHS, then also we have to show the answer is the same, which is tan square a. Let's start with the first bracket as LHS. LHS is equal to 1 plus tan square a divided by 1 plus cot square a. Now use the identity sec square a minus tan square a equals 1. From here we can write, or we can see what is 1 plus tan square a. This is equal to sec square a. So we can replace 1 plus tan square a with sec square a and use the identity 1 plus cot square a equals cosec square a for the denominator. So we get sec square a by cosec square a. Sec square a is 1 divided by cos square a. This is the reciprocal of cos square. Divided by cosec is the reciprocal of sine. So we can write cosec square a as 1 divided by sine square a. Here what we are getting is a fraction divided by another fraction. So the first fraction we write same as it is, 1 by cos square a. Division change with multiplication, and the second fraction we write its reciprocal. So we get sine square a divided by 1. What we are getting now is 1 times sine square a, which is sine square a, that is the numerator, divided by 1 times cos square a, that is cos square a. This is equal to sin a by cos a the whole square. That means sin a by cos a is tan. So we get tan square a. Tan square a is the RHS, right hand side. So we have proved the given identity. Next we are going to take the second bracket, that is 1 minus tan a divided by 1 minus cot a the whole square equals tan square a. So we will consider this as our LHS. Let's start with LHS and we will prove the answer is equal to tan square a. LHS is equal to 1 minus tan a divided by 1 minus cot a the whole square. LHS is a fraction raised to power 2. So we are giving the numerator with the power 2 and the denominator with the power 2. Numerator is 1 minus tan a. We write whole square divided by the denominator is 1 minus cot a and give the power 2 here also. So we get 1 minus tan a the whole square divided by 1 minus cot a the whole square. Next step we write 1 minus tan a as sin a divided by cos a and whole square. Denominator 1 minus cot a. What is cot? It is cos a divided by sin a, then whole square. Simplify the numerator. 1 we can write with the denominator 1 so that it becomes 2 fractions to be subtracted. We can take 1 times cos a, that is cos a as the common denominator, cross multiply to get the numerators. 1 times cos a is cos a minus 1 times sin a is sin a, then whole square divided by 1 in the denominator also we can write as 1 by 1. Now we take 1 times sin a, which is sin a as the common denominator, cross multiply 1 times sin a is sin a minus 1 times cos a is cos a, then whole power 2. Numerator we can give the power 2 separately. So what we are getting is cos a minus sin a the whole square divided by cos a the whole square, which is cos square a. So we can write cos a minus sin a the whole square divided by cos square a. Next the denominator. Here also we can give the power 2 separately. We are getting sin a minus cos a the whole square divided by sin square a. Now it's clear we have 2 fractions to be divided. So what is the next step? We write the first fraction same as it is. So we are going to write the first fraction, which is cos a minus sin a the whole square divided by cos square a, same as it is. Cos a minus sin a the whole square divided by cos square a. Division change with multiplication. Second fraction we will write the reciprocal of that fraction. So we write here sin square a divided by sin a minus cos a the whole square. See the numerator and denominator, cos a minus sin a the whole square and sin a minus cos a the whole square. They are same, a minus b the whole square and b minus a the whole square same. So we could cancel these two same terms. And what we are getting now is sin square a in the numerator side and the denominator is cos square a. So sin square a by cos square a is sin a by cos a the whole square, which is tan a the whole square or tan square a, and that is the RHS. LHS equals RHS means we have completed the proof, and in this part 10 we have showed both the brackets are equal to tan square a. Hope the content in the video is clear to you. If you like this video, please share and subscribe to my channel Math for Me and You. See you with more useful videos. Thank you.